Tell me a little bit about the project. What is this?
This is my team's Senior Design 2 project that we completed in fall of 2020. We wanted to do a project that had to deal with power management. Basically, if you could apply this project to a power utility company, it would help them manage all of the different people who want power at the same time. And that's a difficult problem to solve because not everybody needs the same amount of power at the same time. But when they want power, they want it now. So we've symbolized different customers of this power grid by using 4 different light bulb tracks. And this is actually just track lighting fixtures that you might find in a bathroom. But we used light bulbs because they're cheap, very variable, and we're able to simulate different amounts of power that different customers might want to draw from a power company. We're measuring the power that each customer is using, and those signals get sent to this guy. This is the brain of the whole operation. This is a Tiva microcontroller, and it reads in how much power each track is using, and then it says, okay, how many of you guys can I turn on at the same time without drawing too much power and causing a brownout or a blackout? And then it basically just cycles through the different tracks and says, you guys can turn on at the same time. Now I'm going to give this guy a turn. Now I'm going to give this guy a turn until everybody has received the amount of power that they want.
So in our project, we realized there was magnetic interference, specifically magnetic interference between these low voltage wires and these higher voltage wires. So we designed a plexiglass shield so that our low voltage wires could sit away from our high voltage wires. This reduced magnetic interference and allowed for higher accuracy in our current transformers that are reading the voltages on each line.
These devices are current transformers, which we're using to measure the current draw to each customer. You may remember from a general physics class you may or may not have taken the principles of electromagnetics. So these devices actually don't touch the wires themselves, they just go around the wires. And the current going through the wires creates a magnetic field, which in turn induces a current in the current transformers, which is sent via these wires to each of these circuits that we have built. These circuits turn the signal into something that's more readable and more usable by the microcontroller. This is the Tiva microcontroller. It's the brains of the operation, as I said earlier. And that is the current transformer subsystem.
Okay, so to explain why these light bulbs are switching, as you just saw there, the algorithm runs each line to determine which wattage is being drawn at each line. From there, it can determine, based on what we tell it the max wattage is, how many lines can be run at the same time and for how long. Based on the joules of energy that we want to provide to each line and the max wattage that can be run at the same time, the algorithm then turns the relays to turn on and off the lines depending on which lines are allowed to be on. So as you see, this last line, since there is a total of 225 watts at this line, no other lines can be on with it at the same time, versus these two lines only total about 200 watts together.
For our project, we had to work remotely because of the COVID pandemic. One of our computer engineers is actually remoted into this system right now. He is talking with this laptop from his computer in Easley, South Carolina, and we're currently in Clemson. And he's using a webcam so that he's able to see what the project is doing and troubleshoot while still remaining socially distanced and allowing us to complete the project during this difficult time.